Let h be a function defined for all x not equal to 0 such that h of 4 is equal to negative 3, and the derivative of h is given by x squared minus 2 over x for all x not equal to 0. Part A says find all values of x for which the graph of h has a horizontal tangent and determine whether h has a local max, min, or neither at each of these values, and justify your answer. To find the values of x for which the graph has a horizontal tangent, we're going to take the slope and set it equal to 0. To solve this, it's a proportion, so we're going to cross multiply. You get x squared minus 2 equals 0. And finally, we get x equals plus or minus root 2. Next, it says determine whether h has a local max, min, or neither at each of these x values. So the other thing we want to keep in mind is where this derivative doesn't exist. And it does not exist when x equals 0. So that's going to be another critical value. Okay, now we have all of our critical numbers, so we're going to test them on a number line. So you can see I plugged in values on the number line for h prime. And at negative root 2 and also positive root 2, h prime changes from negative to positive at both values. Therefore, h has a local minimum at both of those x values. And I have that written out. H prime changes from negative to positive at both x equals negative root 2 and positive root 2. Therefore, h has a local minimum at x equals negative root 2 and also at x equals positive root 2. Part B says on what intervals, if any, is the graph of h concave up? Justify your answer. To look at concavity, we need to find the second derivative. Before we do so, I want to simplify this. So we're going to rewrite h prime first. I like to call it the heart. We're going to do x squared over x, simplifies to just x. And you also have negative 2 over x, but I'm going to rewrite that as negative 2x to the negative 1. So now we can take the derivative of this. The derivative of x is 1, and the derivative of this term, we're going to bring the negative 1 down and multiply, and then subtract 1 from the exponent. So for the second derivative, you get 1 plus 2 over x squared. No matter what you plug in for x, whether it be a negative or a positive value, your whole expression will always be positive. Therefore, this function will be concave up for all values except for x equals 0. So I wrote it out. Therefore, the graph of h is concave up from negative infinity to 0, and then also from 0 to positive infinity. Part C says write an equation for the line tangent to the graph of h at x equals 4. To write an equation for the line tangent to the graph of h when x equals 4, we're going to need point and slope. So to find the slope, we're taking 4 and plugging it in for h prime. So our slope is 7/2. And since we're given h of 4 is negative 3, we plug in the slope and the point into the point slope form, and you get y plus 3 equals 7/2 times the quantity x minus 4. And there's your equation of the line tangent to h when x is 4. Part D says, does the line tangent to the graph of h at 4 lie above or below the graph of h for x greater than 4 and y? In part B, we determined that the graph of h is concave up for all values except for 0. So if your graph is concave up, that means any tangent line you draw will be below the line. So I just wrote that out. The line tangent to the graph of h at x equals 4 lies below the graph because the graph of h is concave up for all values except for x equals 0, and therefore is concave up from 4 to infinity. Thanks for watching, and if you could hit the like button and subscribe to Math with Yosh, that would be awesome. Thanks, guys!